All right, everyone. So when I'm making this video today, which is why it's coming up now instead of earlier, my computer isn't letting me make any videos anymore. So this is all having to be done on my iPad. I thought I fixed the problem, but it seems like it's not. The writing might be a little bit more, like a little bit sloppy than what it normally is, even though it's not necessarily the neatest writing. But just bear with me when we do this. You'll see that in each of the questions, the question number is going to be here in the top left hand corner, so you know exactly what question we're on if you want to skip around the video as well. And the video title has all the questions that were being covered on this. All right, so I'm just going to go through one by one and move on to the next one. It's going to be pretty quick that I'm going through it because this isn't new, it's just a review, so it's just kind of going over some things with you. All right, so it says write the function using the correct notation when given the following translation. So remember, using the correct notation, what I mean by that is it just needs to be written as a function. So we can write whatever we want as far as the f, g, or h, but it needs to be written like this: f of x, g of x, h of x. You don't actually have to use x if you don't want to either. You could have said f of n. You're creating your own variable, you're creating your own function rule. It's up to you, but it just needs to be in proper notation. All right, so now I'm going to just use f of x. That's just the one that we normally do. So my function is going to start f of x is equal to. So we learned that we have this f of x is equal to x minus h squared plus k. And our h represents our horizontal shift. And our k represents our vertical shift. So when I see a quadratic function, first off, we need to know what does it mean to be quadratic, and because we have two different ones we've been learning, quadratic and absolute value. And we know that quadratic is the x squared. So we know that we're dealing with the x squared. If it said absolute value, we would have been dealing with the absolute value of x, but that's not what we're doing on this problem. So I know it is going to be in this x squared. So I'm now looking to see, am I moving left, right, up, or down? Well, I'm moving in both ways. I'm moving right and I'm moving down. So that means that I need to take into consideration what my h and what my k is. So when we move 3 units to the right, my h is equal to 3. And when we move 1 unit down, my k is equal to -1 because we move up or down, it's negative, left or right, right is positive. But when I plug it into the formula, you notice it says x minus h. So when I go and plug this in, it's going to be x minus h, which is a positive 3, so it's x minus 3 squared. And then my k is -1, so it will be -1. And remember, you can check your work by looking at the function that you created and saying, when I put this in words, is this telling me I'm moving 3 units to the right? And we learned that we go opposite of the sign that we see because it's part of our negative of our formula. And also we know that if we wanted to get back to our parent function, we would need this square to be equal to 0. So in order for us to make that 0, the x would have had to have been a positive 3. Which is telling us we're moving 3 units to the right. All right, so remember, when we're doing this, we're going opposite of the sign when it's included. So we see that -3, intuitively we want to say, oh, it's going to the left 3, but we go opposite of it because our formula is minus h, right? And when we're going in the other way, we can just go straight with what our signs mean as we move to the right. It does give me a positive 3. And as we move 1 unit down, it does give me -1. And when we plug it into the formula that we learned, it's going to naturally just change it into the correct signs. All right, let's move on to the next one. Question number 3. This one says, evaluate, or given the graph, find when f of x is equal to 9. So we want to know when f of x is equal to 9. And remember, when we see this f of x, it's just letting us know it's function notation, that this is a function. We learned before that it's the same as if we thought when y is equal to 9, but when we write it like this, it's not in function notation, but we can still think about it as we're answering these questions. So we want to know, okay, when y or f of x is equal to 9, we're trying to solve what does x equal. So we then need to highlight that question or that point on our graph, and we see this is where our y or f of x is equal to 9. So then we look and say, okay, well, what x value gives us that? And if we just draw down to the graph, we see that x is equal to -4. So I'd want to see you write your answer like that, or I'd want to see you write your answer as f of -4 is equal to 9. I want to make sure that we're writing it in correct notation in function notation. All right, let's go ahead and move on to the next one. So describe the translation from the parent function in words. So I see that nothing's being done outside of this square. So everything that's happening to this is happening inside the square, and it's part of the square. And as I wrote in the last, on the other problem, we have x minus 8 squared plus k, and when it's inside, it tells us how we move horizontally, left or right, and we go against the sign that we see intuitively. So when we see this, because our formula is x minus h, that actually means that that's a positive 5 that we see there. So this is actually telling me that we're moving, so we move right 5 units. Right? That is all you have to write for this problem. There's nothing else you need to write, just it's moving 5 units to the right. It's not moving up or down at all because there's nothing being added or subtracted outside of that square. Okay, the next question is number 6. Find the 25th term for the arithmetic sequence. So remember, if you tried to just say, okay, well, I see this as plus 4, if you just try to write out all the way to the 25th term, you're not going to get any credit for this question because it's not showing that you know how to solve or apply arithmetic sequences by using the formulas. So it's not just getting the answer, it's also making sure that we're doing what the standards are asking as far as because if I told you to find a 1,238th, like you're not going to count that out, and it's going to make it really difficult or just really long and arduous for you to do. So it's just we need to be able to solve this in a more quicker and precise manner. So we actually need to come up with our formula or rule first. So a sub n is equal to d times n minus 1 plus a sub 1. And remember, a sub 1 is our starting point, our starting number. And our d is our difference. And we leave n as is because that's telling us what number term we're looking for. So n is our number term. So in the beginning, for us to get our rule, we're just going to leave it as n. So now what I'm going to do is identify, well, what actually is our difference and what actually is our starting number? Well, a sub 1 is easy to find because it's just the first number in our sequence, so it's 17. Our difference, we then just need to look and say, okay, well, how is this changing? From 17 to 21, we are adding 4. From 21 to 25, we are adding 4. So our difference is equal to 4. So a sub n is equal to 4 times n minus 1 plus 17. And now we just simplify. A sub n is equal to, we distribute this in, 4n minus 4 plus 17. A sub n is equal to 4n plus 13. So now that we know what our rule is, we now can find any number that we want in this. So if I ask you to find the 1,000th term, the 1,000,000th term, we can. So now I'm asking you to find a 25th term, so that means when n is 25. So we will then say a sub 25 is equal to 4 times 25 plus 13. Well, 4 times 25 is 100, plus 13 is 113, so a sub 25 is equal to 113. And this is how I want you to write your answer, because by writing it the subscript, you're telling the reader that this is the 25th term we're finding, and it is equal to 113. So you must write your answer in that way of a sub 25. Okay, identify the vertex when given a following translation. So remember, when we're identifying the vertex, it's our point of our graph where we stop and turn around. So in this case here, we can think about it in terms of words, but this is telling us we're moving to the right 8 units. We're moving down 2 units. So we can represent the right by a positive 8. So I know that, and since we're moving left to right, that's my x value in my vertex, because our vertex is an x and y ordered pair. And since we're moving horizontally with this 8, it's telling me my x value, and then since we go against the sign, we're moving to the right, that's a positive 8, so my vertex for x is 8. Then we're moving down 2, and when we move up or down with our parent function, we follow the sign, so down 2, we know that means negative, so our vertex is 8, negative 2. All right, this one, evaluate the given piecewise function for when f of x, or for f of negative 5. So remember, normally we write it as f of x as we see here. And when we write f of negative 5, we have replaced or substituted that x with a negative 5. So we're essentially asking, what does, when x is equal to negative 5, substitute in and find out what our function is equal to. In a piecewise function, though, it's a little bit more than just what we're used to with plugging it in. We have to identify our domain, and we see that there's a restriction here. So we have 2 separate domains. When x is equal, or when x is less than 0, when x is less than 0, this is the function rule that we use. So any number that's less than 0, we would use this rule, all right? And any number then that is greater than or equal to 0, we would use this rule. So when we're asked to solve for this, we need to first determine, well, which rule are we using? Which domain is this part of? And since -5 is less than 0, we will be using, let me use the same color, we will be using then the purple rule. So that means that this problem, we don't really care about this rule or that domain right now because we have already simplified it and narrowed it down that we must use this. So now let's think about this for a second too. If I told you y is equal to, because we know that that's just another way that we can write f of x, it just means it's not a function. If I said y is equal to -12 and I said, well, solve for what y is when x is equal to -5. Well, there's no variable for me to plug this in, so when x is -5, y would still be -12 because y will always be -12 in this example. So when I do this and I go to solve this problem, I see, okay, well, I know I'm using this domain, so I know I'm using this rule, so f of -5 is equal to -12. There's no variable for me to plug in and do any math with. So any number that is less than 0, if we were to think about like getting an, it's always going to be -12, no matter what. All right, so that means we can write our answer like this, or you can write it as x is equal to, not x is equal to, or you can write it as an ordered pair of -5, -12. All right, so these are the two ways that you can write your answer for this. Because if you write f of x is equal to -12, well, I don't really know what you mean by that because what value of x is generating this -12? So I want you to be very clear that it's -12 when we have that -5. So I want to see your answer in one of those two ways. All right, write the function using correct notation when given the following translation. An absolute value function moves 9 units down. So once again, we see that it's the absolute value function, so I know it's going to be the absolute value of x. We learned that f of x for absolute value is the same exact rules, where it's the absolute value of x minus h plus k, where h is our horizontal shift, just like it was with our quadratics, and k is our vertical shift, just like it was with our quadratic. So it's really nothing new. So we see that we're not moving anywhere left or right. So that means that there is no vertical shift or horizontal shift. So when I go to write this function, I know it's just going to start out as the absolute value of x because we didn't shift our parent left or right at all. And since horizontal is h is our horizontal shift, in that sense, we're looking at h is equal to 0, and we don't need to write x minus 0, so we can just write the absolute value of x. Since we're going 9 units down, that's our vertical shift, and since we're going down 9 units, we know that that means that it is going to be a minus 9 on the outside, because we go with, we move vertically. If it's up, it's a positive number. If it's down, it's a negative number. So there's really no tricking you on that one. It's all intuitive when we're moving up or down. All right, so this is our answer here. The next one, question number 16. Let's go back to black. Determine if following is an arithmetic sequence or not. So I'm going to do blue here. So if we're just determining if it's an arithmetic sequence, every term has to be added by the same difference to the next term. So here I see it's plus 0. Here I see it's plus 1. Right away I can stop. No, this is not an arithmetic sequence because we are not adding the same difference to every term. All right, you notice it changes for some of them. Yeah, maybe here it's also plus 1, but now it's plus 2, plus 3, plus 5, and so on. So it's not the same difference being added. So this is not an arithmetic sequence. Your answer on your test, though, needs to be y. So you would have to explain, all you need to say is no, they're not being added by the same difference. Perfect. All right, let's move on to the next one. All right, question number 22. Identify, this one on your paper is just the range, but just to do 2 questions with once, we're going to both do the domain, and we'll also do the range in the same question. All right, so we'll do them here. So remember, when we're dealing with our domain, we're dealing with our x value or our input. So we're seeing what values of x can we actually plug in. So I see that my graph along my x-axis only goes from here to here. So no values to the right or to the left of those lines can be plugged in. So I need to look and say, okay, well, that means here the furthest left I can go is -3, and the furthest right I can go is a +1. I can't go anywhere beyond those. So x must be less than 1, but also greater than -3, because we're including all the numbers in between there. We have a graph that includes every single number in between there. So we know that our number is going to be between those 2 points. And we notice these are open circles, and we learned earlier in the year that when we're graphing x is greater than 5, we know that that was an open circle at 5. And if x is less than or equal to -2, we knew that was a closed circle at -2. And we talked about this in multiple ways throughout the year as well. So because they are open circles, we are not including those values in our domain. So that's why it is just greater than and less than and not equal to. All right, now the next one is the range. So the range is not our x, but it is our y values or our output. So now when we're focusing on the range of this graph, we're now looking at our y values. So I'm going to go ahead and delete this. We're now looking at our y values. So from here, we see, okay, well, the highest we can go for our y is 3, and the lowest we can go is -3. So I can go ahead and write those out. And since it's range, we're using our y's. So our y can't be greater than 3. So I'm going to make sure I have it less than 3. And it can't be less than -3. So I have to make sure my y is greater than -3. All right. Some of you, when you're writing your answers, you're writing this reversed. You're writing 3 is greater than y, which is in greater than -3. We do want to make sure that we write this. When you're writing your domain out individual points, I'm not taking off points if you don't put it in a proper numerical order, but these, we always read our inequalities left to right. So we should be, we learned this already. This isn't anything new. When we're writing inequalities, they do need to go least to greatest from left to right. All right. So now from here, same thing, since these are open circles and not closed, they're not included with those numbers. So we're not going to put equal. So this is our range and this is our domain. Okay, let's move on to the next question. Determine if follows a function or not. So here we're given a bunch of points. We could, at every single point, just draw a vertical line going through them. And as long as if no point or any of these points don't touch the same vertical line, then we know it's a function. But here I see that these 2 points touch the same vertical line. So no, it fails the vertical line test. And if we were to think about this as well, this 3 gives us 2 answers. It gives us 2 y values. It gives us a 2 and it gives us a 4. And we can't have the same domain give us 2 different y values. So no, it fails the vertical line test. Describe the translation. So question number 24. Describe the translation from the parent function in words. Remember, it is f of x is equal to x minus h plus k. This is our horizontal shift. So this is telling me I'm moving left or right, but since our formula is minus h, we go against the sign that we see, the counterintuitive in ways. So this is actually telling me I'm moving to the right. Let me just erase this. So I'm moving, so moves right 2 units. But I still have this plus 8 on the outside, which is our vertical shift. And remember, since this says plus k, we go with the sign, so it's up 8. I'll just write it like that, up 8, and we go with it. So that means that this is moves 2 units right, moves right 2 units, and up 8 units. And that is our final answer for that one. Number 25 we're on now. So we're asked to find f of 1/2 when given this function. And remember, we write our functions as f of x. So all we're doing here is substituting 1/2 in for x. So it's just another way of saying solve for your function, or y if you want to think about that, because that's what we're kind of used to doing it as. Solve for y when x is 1/2. So we simply just need to substitute it in. So f of 1/2 is equal to -10 times 1/2 because we substituted our x in with a 1/2. So in our function, we need to substitute 1/2 in for x. So f of 1/2 is equal to -5. Oops, I don't know why I wrote minus 12 there. -5 minus 15. So f of 1/2 is equal to -20. So this is how you will write your answer, or you can write it as 1/2 comma -20. If you just write -20 as your answer by itself, you're not proficient. And if you wrote f of x is equal to -20, you're also not proficient because it's not being written in a correct format. I won't be able to know, well, we are asked specifically when x is 1/2. So we need to know that that's the domain that gives us the range. So that's why neither of these will be acceptable. Okay, for number 27, given the function f of x is equal to 2x minus 14, find when f of x is equal to 20. So you see the last problem we did, it said f of 1/2. It doesn't say that anymore. So we said f of 1/2. Here it says f of x is equal to 20. It's the same thing as saying when y is equal to 20, because f of x is another way of writing y, but letting us know it's a function. So what we need to do then is wherever we see f of x, we need to replace it with 20. So this is just another way of saying, well, 20 then is equal to 2x minus 14, and we're trying to solve for x. So I'll add over 14. 34 is equal to 2x, divide by 2. So x is then equal to 17. This is how you can write your answer because we are just trying to solve for x. Or if you wanted to, you could also write it as 1720 as an ordered pair, and that works as well. But those are the two ways that are acceptable to get proficient for this question. Okay, now we're on to question number 28. Identify the range and domain. So same thing. Your question only had one at a time, but just to be able to do two questions at once, and this was one I think some people struggled with, just want to make sure we go over it. All right, so when I see my domain, I see that, remember, it's input and output. So since the arrows are being drawn in this direction, that means that our input and our output is here. So these are all of my domains. So when we're writing our domain, we need to write it as a brace, and then we just write them preferably in numerical order, especially it's written for you in numerical order here. But remember, for now, when we're doing discrete domains and ranges, I won't take off any points and you'll still be considered proficient as long as you have all the correct numbers. So all of these numbers have a line being drawn from them, so all of them are part of our domain, so that is our answer. For our range, however, though, even though they list -8, 4, 9, and 13, there's no arrow that goes to them. So none of those numbers that we see are actually part of our range because none of the input gives us that as the output. So our only answer in this case is 7. Because it's the only one. All of them actually give us that 7 as our answer, and we can have different inputs give us the same output. That's fine. So the only number that actually is being used here is that 7. So the range is simply just 7. All right, move on to the next one. Number 29. So we're asked to evaluate the given piecewise function for f of 10. So once again, we usually think about this as f of x. So the x was replaced with 10. So we're simply saying solve for our function when x is equal to 10. So when it's a piecewise, we need to figure out, well, which domain is it part of? So there's two separate domains we have here. We have blue and we have red. Well, x is 10, so I look, oh, I see 10 for both of them. But this is less than 10, and this is greater than or equal to 10. So it's not part of this domain because it is not less than 10 since it is equal to it. So it's part of this domain. So that means I will use this function rule of f of x is equal to 5x. So I'm trying to solve for f of 10. So I simply just now substitute 10 in for x. So f of 10 is equal to 50. This is how you can write your answer, or 10 comma 50 is how you can write your answer as an ordered pair as well. Either one of those are acceptable, but that's the only way that you can write it to be considered proficient for this question. All right, number 16, we're creating just a rule. So we're not trying to, I'm sorry, number 30, not 16. We're trying to just create a rule for this one. So we don't have to find any nth term or anything like that. We're just creating a rule. So remember, our rule is a sub n is equal to d times m minus 1 plus a sub 1. So in order to find this rule, we need to figure out what does d equal and what does a sub 1 equal. Well, a sub 1 is easy for us to find because it's just simply our starting number. So a sub 1 in this example is -13. So that one's really easy for us to find. When we're doing our difference, all right, to go from -13 to -19, I am subtracting 6. To go from -19 to -25, I am subtracting 6. So my difference is equal to -6. All right, you see that our numbers are getting smaller. -13 is less than, I mean, smaller in quotations. -19 is less than -13. -25 is less than -19. So we're decreasing our value as we go. So it tells us our difference has to be negative. All right, so now just plug in a sub n is equal to -6 times m minus 1 minus 13. And then I just need to simplify. I'll distribute the -6 in. So a sub n is equal to -6n plus 6 minus 13. And then we just finish with the a sub n is equal to -6n minus 7. And that will be our rule for this given arithmetic sequence. And that is it for that one. There's 2 more questions and then we're done with this video. All right, so now this next one that we will do, determine if follows a function or not. So we're just answering yes or no. What we need to look for in a table or when we're given an ordered pair is, do we have any x values that repeat that then give us different y values? Because that means that it would fail the vertical line test. Oops. So I see here that I have 4 twice. right? So since I have an x value that repeats, I need to check and see, is it giving me different y values? And yes, it does. So if I were to sketch this real quick and say 4 and negative 20, we would have a point there. And then 4 and negative 14, we would have a point there. And that would fail the vertical line test. So, whoops, no, it is not a function. And our reasoning would be that we have an input that, we have one input that gives us two different outputs. All right, one input gives us two different outputs. That's all that you need to do to explain it. And that lets me know that you understand what you're doing. And if you want to talk about it would fail the vertical line test, you need to say if we graph this. All right, because if you just say no and vertical line test fails, like that's not telling me that you really understand, because you just know that we have used a vertical line test and how does it apply to this. When it's graphed, you can just say vertical line test because I know that you're referring to the graph. But since it's giving us points here, you would have to specifically say that if you plot these points, it would fail the vertical line test. Or you could say the same input gives us two different outputs. Right, and then the last question that we're doing is identify the vertex when given the following translation of parent function. So we're looking for an xy value. We know that we normally have f of x is equal to x minus h squared plus k. So since I see nothing is being added or subtracted to this x squared, I know that that means that there is no no horizontal shift. So I can go ahead and cross that out. And then since we're not moving left or right, I know that my order or my vertex has to be a 0. And then I see this plus 14 on the outside, and that is our k. It's telling us how we're moving up or down, our vertical shift. And we go with the sign, so it means we're going up 14. So that means it will give me a positive 14. So our vertex would be 0, 14. All right, that is it for this video. It is not mandatory, but you can skip around if you need to.